Howdy everybody, and welcome back to the Megaman tutorial. Last time we set up the climb state and the jump state for the player, and I promised that we go into some of the nitty-gritty of the math used to make the climb state work properly. So let's get cracking. If we come back to our climb state here, we can just come on down to here, move with tile collisions. Right click that to pop open our code. And let's make sure that we can see everything in here. Alright, so where are we at? So there's a lot of stuff going on in the collision script. That's why there is a separate video on how this thing works. So make sure you go and watch that separate video. I might want to make a updated version in the future to include some of the new changes and to improve the code and stuff. But for now, we're going to ignore the horizontal because we don't collide with ladders when we are going horizontally. We just sail right through them as if they weren't there. So our only real collision with ladders is vertical. So we come on down here. We need to check and see if what we are colliding with is a ladder. So P3 here. This is checking if the center pixel of our character at the base of the character is a ladder tile. And if it is, then we are on a ladder. So underscore P3 is equal to 3. And if we go back to our tile sets, our collisions, 0, 1, 2, 3. So if it is 3 and our Y speed is greater than 0, so therefore we're going down, then if we are above a ladder tile and going down, treat it like a solid. So if we are walking over a ladder tile, just treat it as a solid. Otherwise, go through it. So if tilemap underscore get at pixel, tilemap bbox left, bbox right, bbox left, so middle, target -1 if the tile underneath us does not equal 3, and that means that we reached the bottom of the ladder. So therefore, drop us off. Y equals, it sets us to the bottom of the ladder and sets our Y speed equal to 0. And otherwise, just Y plus equal speed. That's just the normal collision stuff. Alright, so that was fairly quick and painless, I hope. So what are we going to do next? We got a move state for the player. And we got a climb state. And we have a jump state. But what we don't have currently is a shooting state. Because one of the key things that Megaman does is shoot stuff. So we need to add in the ability to shoot things. So let's come over to our move state. And we're going to want to pretty much copy the entirety of the move state. And we're going to add a new user event. I'm going to call it user event 1. And we'll call this move shoot state. And I'm just going to paste in all that code into here. And we are going to do a little bit of work here. Coming over to the, so collapse that, we don't need it open yet. Acceleration, we do not need this because we don't skid while we're shooting. and speed fractions should be the same. Collisions should be the same. So we can ignore all that for the most part. As far as animation goes, leave this here the same. Leave in the skidding part, though I don't think we need it. So we can actually probably eliminate that. We just want to be able to go idle, and for that we just need to be able to go to image speed equals 0, manual sprite change equal choose, and instead of sprite man idle, we do sprite underscore mega underscore man underscore shoot underscore stand. And the rest of this, all the calculations for blinking, we can ignore. Else image x scale is equal to the sine of x speed. And cut that as well. And I have this in here. I don't think we actually use it anywhere in the code, but we'll leave it there just in case it was important for something. So we've put in all this stuff from the move state. So how in the world are we shooting? Well, we need to put that into our states. So we'll actually come back to our move state and collapse all this code so it's not visible. We're going to add a new state that we can move into here called the shoot state. And there's a lot of logic that goes into being able to shoot properly here, so let's get started on that then. So first off, we need to set up ourselves an if our B is pressed and instance number of object buster shot is less than 3, then continue on. Now we need to create a buster object, so let me pop that open here. Yeah. Let me zoom out here. Just over in player objects, create an object, obj underscore buster underscore shot. For now, we'll just give it a image, Megaman, no, not there, weapons, sprite ammo. There we go. We'll just leave that as is. Then we need to do some other stuff here. Zoom you back in. State underscore is equal to player underscore states dot move underscore shoot. Oh, yeah. Now that we're talking about changing states, back a couple episodes ago, I mentioned something about how your sprite would not be in the right sprite when you're calculating the movement for the player sometimes. And part of that problem would be because of this right here. We're setting our state equal to the move shoot state, and then of course we tell it to eventually state execute, right? So that means we're changing from our running sprite into our shooting sprite, but we're not actually changing our sprite when we change state. So we do all the calculations for the first frame of whenever we're in a state using the wrong image, if that makes sense. I hope it does. So in order to combat this in the future, what I need to do is I need to remember to execute the this as part of the state change code. Zero, 1, 2, and 4. There we go. Getting that right. I keep trying to look for the user event 0, and I'm trying to look over here for it, but it's completely in the wrong position. Anyway, so yeah, we'd have to manually update the, we'd have to make sure that we update the sprite before we do any other thing, actually. Maybe I could even move this over here too before the user event or something. I'll have to figure out the exact logic of it in a future tutorial for now. But for now, we'll just keep going as we're doing. Just like with the jump state, we need to use up our input buffer. We stay in this state for 0.2 seconds. And pound region create bullet. We're going to keep a sub-region here because we are going to be creating bullets, and so there's a big switch here to determine what bullet we are creating for whatever position in time. But after all that is said and done, we need to remember to set our image underscore speed equal to 0, our image underscore index equal to 0, event underscore user, state underscore, and exit. So we don't end up double calculating our state. Create bullet. For the moment, we're just going to have the buster, so we'll do switch weapon underscore and case weapons dot buster break and we need to remember we need to do this. So when we create a buster shot, we need to play the sound buster shot. We need to create a buster bullet, and with that bullet, give it a speed of 4. I could actually just kind of put this as part of the buster bullet itself, probably. But apparently I put it right here for whatever reason. So we got this now, and the buster shot itself has a bunch of code inside of it. It's basically a miniature player object. If you come in, so let's just set all that up. So we have animation area, we have image speed, animation speed, direction facing. Currently have it set up so that it looks for the player object and then bases what direction the bullet is facing based on what direction the player is facing when the bullet is created. That way, if the player is facing right, the bullet will be facing right too. If the player is facing left, the bullet will be facing left. Image X scale is equal to direction facing, so that will determine whether it's left or right by 1 or -1. We're just flipping the sprite. If you had actual different sprites for the left and right, you would be able to set that up as well. State is equal to object player dot weapon. Animation underscore timer is equal to 0. And first round underscore hit underscore is equal to false. This is for bouncing bullets, which we'll put in here as well. Then we have the X fractions, X input, Y input, accelerations, frictions, gravity, max speed, fall speed, X speed, Y speed, all this stuff. We're not actually going to use all of it, but it's in there because we might want to use it because it's going to be moving in ways that approximate the same way the player moves. And of course we have this sprite lookup table. Again, this is, I probably didn't have to do this at all. I could have done something else completely different. As you can see, we're not even using like the player's sort of sprite lookup table, where they have a array of different sprites. In this case, I just have a switch, so it determines what sprite index it should be based on what sprite, what weapon it currently is set to, and what damage the weapon should be doing, and so on. So let's go over to the step event. This is easy. Just execute the state. And add event other, user event 0. And again, this should be very easy. The buster shot just goes in one direction. X speed is max speed time direction facing, and X plus equal X speed, Y plus equal Y speed. Don't even do collisions because it just flies through everything up until it hits a object that can be hit by the bullet, at which point it would disappear. So there's nothing really important going on there. Alright, back to the player's state. We should be able to create a bullet now. The bullet should fly off into infinity, of which actually, if we come over to our parent group, we need to create another parent. Parent underscore projectile. Give you the projectile parent. And what the projectile parent is going to do, going to go over to other views, outside view 0. We're just going to say whenever you go outside of the room, instance destroy. Whenever you go outside of the view. Because we don't need the bullet to be going off the screen. Alright, good. Let's see what time we got. We are at 17 minutes, so when we're in the move shoot state, we need to be able to exit that, right? That's probably fairly important. So before we actually go off to do anything else, let's go back to the move shoot state, and let's move back to the move state. There we go. If our animation timer has reached -1, so yeah, we need that there. Then we return to the move state, make sure all of our image speed, image index, and everything are alright, and we're done. That's fairly easy, right? But we have two other major states that we're moving around in. So we have the jump state and the move state, and the shoot state and the climb state. So we need to be able to come back to our objects. So, oh, that would actually be very important. I completely forgot to be able to put in the ability to move into the climb state into here. So we should actually address that before we do anything else. So, when here we go. If our input for up or down is pressed, then we want to make a check to see if there's a ladder underneath or above us. So, We do a tile check. At our we find our center position, and we have place 1, place pixel 2, pixel 3. Check at our B-box bottom, +1, so that would be check for a ladder underneath us. 2, check to see if we're already at a ladder. And 3, check to see if there is a ladder above us. Then, if any of these are true, then we need to get on to the ladder. If we are pressing up and let's see, any is a script I made that just returns true if any variable is equal to the given value. So in this case, if any of these are equal to 3, which is to say a ladder tile, and that'd be something actually in the future I'll probably set up an enum or something for, so I can do instead of 3, I do enum. I do a enum for like collision tile.ladder or something like that. So if up is pressed and P2 or P3 is equal to 3, so if P2 or P3 is there, so at our B box bottom, so if the ladder extends all the way to the ground, and our top +1, that would be if the ladder extends all the way to just above the player object. And there is no instances of that happening in Megaman, I think. So for the most part, this is a check that doesn't even need to happen. But it's kind of useful if the ladder's in midair, I guess. Actually, there is an instance of that right there. But there isn't really anywhere the player is standing right here and the ladder is right above his head. So if there is a position, so back to on track, if we do end up with a ladder tile being detected, then we need to say var_x is equal to tile map get cell x at pixel. So what we're doing here is we're finding out at our B box top what is the X position of that cell tile. So you see the grid here. This is finding this X position of the left side of the grid at this tile's location. And then we set Rx equal to this X position plus our B box right minus B box left times 0.5, our center. Which I could probably erase this, and well, no, I can't put center because we actually include this B box left to make sure that this is our center relative to the room, and this is our actual half width, I should say. So clamps me to the ladder, and Y minus minus. This makes sure that you aren't on the ground when you enter into the climb state. So that way you don't accidentally immediately detect that you are on the ground, so therefore you must get off the ladder, because then you would end up trying to get onto this ladder and you just keep getting thrown off of it again immediately. Set ourselves to the climb state, x speed equals 0, or you can start floating sideways. Yes, I did this a couple times during my when I was doing testing. I would be moving to the left XYs, and then I would I'd clamp onto the ladder, but the X speed would carry through, so Megaman would just go flying off the side of the screen for no reason. Set our image index equal to 1 because that is the let me pull open the sprites. One is Megaman climbing, yep. And of course, execute the state. Else if object can put that down pressed and NE3 is equal to P1. Then we do kind of the same thing. Get the X information so we can clamp ourselves onto the right position. Then Y plus equal 14. So this is the height of the climbing sprite B box plus 1 minus the offset for exiting the state. We don't need this part anymore because I got the code set up so you don't need it anymore. So you just when you climb on when you're up here and you press down, you want to get onto the ladder. So you jump down by 14 pixels so that your character is on the ladder completely. Pretty much the same as this Y minus minus right here. Set ourselves equal to the climb sprite. And set our state to climb. This is like I was talking about how we need to change the sprite when we change state directly so that we do our collision checking properly. X speed, of course, equal to 0 again. Image index equals image speed is equal to 0. Image index is equal to 1. And the code inside of the climb state will check for us and make sure whether or not we are doing that little crouched over or the actual climb look at that point. And exit. Okay, so we've done a lot of stuff. I need to make sure that it's all working properly. Megaman moves. He jumps. Good. How about shoot? Yeah, we can shoot. Good. You mean, he can only do 3 bullets at a time. That's important. Though, we can't shoot while we're midair. Also, we don't have this set up completely yet because, as you can see, I'm smashing this as fast as I can, but I can't really get out the bullets that fast. That's because we are waiting for us to exit the move shoot state before we're able to shoot another bullet. But next time we'll add in the ability to just keep shooting while in the move state. That way we can get off 3 shots really fast. And also to allow us to, well, get off the 3 shots really fast. Let's come over here and check and see if ladder is working properly. Alright, see we're able to walk over properly and get on. And off. Right off the screen. Alright, thank you everybody for joining me. I think we'll do some Patreon names and we'll call this a day. So let's pop open the Patreons. Special thank you to Fragile Hearts, Crew Patreon, Damien, Kenneth Klein, John Dickey, and Vladimir Soldatov. And if I've managed to mangle your name, consider it an honor. I'd like to again say thank you to everyone who watches, let alone those who have provided monetary support. Your views are greatly appreciated. And anything else? Nope, I can't think of anything else. So if you have a comment, leave it behind. I'll try to help you out as best as I can. And thank you, everybody, and good luck with your programming.